Okay, guys. Okay, so if you look at this question, yeah. So, okay, the attempt was made to compress a gas and a solid using the apparatus shown. Okay, so which substance will be compressed and what is the reason for this? Okay, so you have gas and solid. So, Jesse, can you tell me whether solid can be compressed or not, Jesse? Okay, so basically, the one that will be compressed will be gas. So the reason, why they can be compressed, because they are far apart. Solid cannot be compressed because they are close together. So the answer is going to be B. Quite simple question. So let's move on to the next question. So here, a sealed conical flask contains liquid and its vapor is as shown. What happens when a molecule in the vapor enters the liquid? So will the molecule stop moving? Will the molecule become smaller? So this one, so do you think, Sydney, do you think the molecule will become smaller if the gas vapor go into liquid?
No.
The size remains the same. So molecules cannot become smaller. Even you compress, you are compressing so that they are going to, the distance becomes smaller. But we never actually say that we can compress until the molecule becomes smaller. This is not like movie, like Black Adam movie, like Atom, the guy who acted, so suddenly it can become bigger and can become smaller. Not like that, So molecules do not become smaller. So the answer can be either this or this, And then related to, what happens when a molecule in vapor enters the liquid? Does it stop moving? The answer is they do not stop moving. They will still move, but not as rapid as it used to be. Because gas, they like to move a lot. But now when they enter the liquid, they still can move. But it's not going to be able to move as rapid as it is going to be. So the answer is going to be, the best answer is going to be D. Now, what could be the melting point and boiling point of water containing impurity? This one, we have done this. I think we had one entire lesson to talk about impurity. So Michelle C, can you actually tell me what will happen to the boiling point and melting point? Pure water boiling point supposed to be 100. Melting point supposed to be 0. So what will happen if you put impurity? Okay, I cannot hear you clearly. So can you answer again?
There are 2 Michelle C's, sir.
Oh, 2 Michelle C. So you, the one who's answering me. Michelle Christabel Ginato.
D.
Rather than answering directly, can you tell me what will happen to the boiling point? Increase or decrease?
Increase.
Impurity will make the boiling point to increase. Boiling point increase. What will happen to the melting point?
Decrease.
Decrease. It will go over there. Decrease. So melting point is going to be decreased. So let's actually look at the value. Melting point should be decreased. Boiling point should be increased. So the answer is going to be D. So Michelle, Michelle Ginato. Thank you. Now, so number 4. Which of the gas have the slowest rate of diffusion? Now do remember, diffusion works similarly like human beings. So if you are very big, you are going to be having difficulty to move. So you will move slowly. If you are small, you are going to be able to move rapidly. So slowest rate of diffusion means they are talking about which of the following is going to be the big molecule. Which one difficult to move. So how do we know which one is going to be big molecule? You have to calculate. Okay, ammonia, you should know ammonia is NH3. By this time, yeah, you see this is MYE paper. Ammonia, NH3. Sulfur trioxide, sulfur tri means 3, yeah, so SO3. Methane, you should know CH4 by now, yeah. Nitrogen dioxide, 1 nitrogen, 2 oxygen. Okay, you write down this first. Then after that, okay, you need to actually look at the periodic table, okay, and then, okay, find the relative atomic mass, okay, for nitrogen and hydrogen. Okay, this one I leave it to you, yeah. You go and find out. Nitrogen is 14, okay. Look at the biggest number, yeah, not 7, so 14. And then hydrogen is 1, so there are 3, so you add, you get 17, okay, for ammonia. For sulfur, okay, sulfur, if you go and look at the periodic table, I have the periodic table with me now, yeah, so you guys have to refer as well. Sulfur is 32.1, okay, 32.1, and then oxygen 3 times 16. So I calculate 32.1 plus maybe 48, roughly I have, okay, 48, so 10, so 80.1, okay, 80.1. Methane, okay, 12 for carbon, 1 for hydrogen, so you plus 4, you get 16. Nitrogen, okay, nitrogen is 14, so 14 plus 2 times 16, so 32, so total you will get 46. So from here, okay, so Jesse, which one is the biggest molecule over here? Okay, sulfur trioxide, biggest molecule, so they are going to be diffusing the slowest rate, yeah. So that's the answer for number 4. Okay, number 5. Okay, students take 2 gram sample of calcium carbonate. 2 grams, you must use balance. Okay, correct. Okay, then add them to 25 cm cube sample of dilute sulfuric acid. Okay, 25 cm cube must have measuring cylinder. Okay, correct. And then at different temperature, how do I know different temperature? Must use thermometer. Yeah, so this one cannot be the answer. Yeah. So, and then she measures how long it takes for the effervescence to stop. How long? It means she is measuring the time. Okay, clock. So this one also cannot. Then, okay, this is extra. You do not need to use filter funnel. Filter funnel we use, okay, when we are using the pipette, yeah, and if you want to do filtration and so on. So the answer is going to be B over here. Now, next, the table gives the solubility of 4 substances in ethanol and in water. A mixture containing all 4 substances is added, okay, to ethanol, stirred and filtered. Okay, solid residue is added to water, stirred and filtered. Okay, the filtrate is evaporated to dryness, leaving a white solid. Okay, so let's actually see one by one. Yeah, so the mixture, okay, containing 4 substances added to ethanol. Okay, and then stir and filter the solid residue. Okay, so the solid residue, yeah, so it means that the solid residue, if you have a solid residue, it means the solid residue, okay, they are not soluble in ethanol. Yeah, if they're soluble, you are not going to have solid residue. Yeah, so first we know that it is insoluble in ethanol. Okay, the solid residue then added to water, stir and filtered. We take the filtrate. Okay, if we take the filtrate, it means that, okay, the solid residue is dissolved in water, so it is soluble in water. Okay, so evaporated to dryness, later giving you a white solid. Yeah, filtrate, okay, filtrate is going to be evaporated to dryness, leaving a white solid. Yeah, so this is going to be, the answer is going to be B. Now I just want to check again, okay, see whether you can still remember this. So if I have a filter paper and then I filter this out, Okay, if there is something over here, okay, Max, can you tell me what is going to be the one over here, if it is solid residue over there? Hurry up. If you are not sure, just say no, not sure, yeah, I will just continue.
Not sure.
Okay, Jake, can you tell me what is that?
The residue part.
Okay, this is residue. Okay, Brian, can you tell me what is this?
Filtrate.
Yeah, filtrate. Okay, please remember this, yeah. So in order to answer this question, you need to actually understand this concept, yeah. So if there is residue, means they are not soluble with that, yeah. If filtrate, it means they are already soluble. You take the filtrate, then evaporate to dryness, leaving the white solid, yeah. So it means that
How come the water one soluble? That one still leaves solid, right? So it's insoluble.
yeah, because they are soluble, that's why they leave white solid. So it means that, okay, they are soluble. That's why it contains water and the white. Maybe let's say I give you one example, KCl. Okay, water and KCl. So water, KCl is soluble in water. Yeah, so KCl solution. So when I take this sample and I evaporate to dryness, I will get, okay, only KCl, okay, white solid. The rest all water will go out. Okay, that is what they mean, leaving white solid. It means the white solid earlier was able to dissolve in water. Is that clear, Jake?
Yeah.
Okay, so the answer is B, yeah. So let's actually move on to question number 7. Now this is a fractional distillation. How do you know something is going to be fractional distillation or simple distillation? Okay, you look at this fractionating column over there, yeah. So that's very important. Now, which statement explain why ethanol is collected as the distillate? This is the distillate, yeah. So it means that if you have ethanol and water, it means that there are two particles that are competing to each other. Which one to be changed into distillate? So it means that we are separating them based on the boiling point. So whether we are going to use ethanol or water to be going first, okay, it is determined by the boiling point. So it means that, okay, the one that can boil first, they will be able to be collected as the distillate. So in this case, if ethanol is collected first, it means ethanol is able to be boiled first. It means that ethanol will have lower boiling point, okay, compared to water. Okay, if you want to memorize also, you can memorize. Okay, boiling point of water is 100 degrees Celsius. Ethanol, the boiling point is about 70 degrees Celsius. Okay, so if you look at this, statement, okay, you have to look at it in form of boiling point. Yeah, so ethanol has higher boiling point than water. No, yeah, because ethanol should be able to boil first before water, yeah. So it must be lower boiling point. So lower boiling point than water. Okay, nothing to do with density, nothing to do with insoluble in water. But anyway, ethanol is soluble in water also. Yeah, but the answer is going to be C. Okay, the one that will change into distillate is the one that is going to be able to change into gas first. The one that is going to be able to change into gas is the one that has the lower boiling point. Yeah. And what is the function of the glass beads in the fractionating column? Okay. Sometimes, because most of the time we are dealing with the heat, water will also go up. Okay. And then ethanol will also go up. Okay. But water, okay, being heavy, okay, sometimes it's actually not to say just heavy only. Okay, because they are higher boiling points. Okay, therefore, as they keep on going up, they will lose energy. Okay, when they lose energy, the gas or water vapor, they will start to condense. Okay, they will start to change into because they take a lot of time to move. Okay, so they will start to change into water droplets, and they will drop first. Okay, they keep on dropping. Okay, but ethanol being lower boiling point, yeah, they will actually keep on going up. But the thing is, you need to be careful. You provide the heat, yeah, you provide the heat so that the thermometer reading do not, okay, make sure do not exceed, okay, 100 degrees Celsius. If you exceed 100 degrees Celsius, whether they are going to take time or not, okay, water will be able to go up and then mix with ethanol. In the end, you are still going to get ethanol with water over here. So make sure that this temperature do not exceed 100 degrees Celsius. So we need to control so that we can only get ethanol. Okay, but make sure the temperature is greater than 70. Yeah, if you do not have enough temperature which is up to 70, nothing will be collected also. Yeah, so please take note of that. Okay, next question. What is the SI unit for measuring volume of a liquid? Okay, the SI unit to measure the volume for the liquid is going to be meter cube. Okay, meter cube, cubic meter. Okay, that's going to be the SI unit for measuring volume. Because the SI unit to measure length is going to be meter, okay, not inch, okay, because not inch, okay, not centimeter, okay, meter. So the SI unit for measuring volume must be meter cube. Yeah, don't go and write down liter, okay, dm cube, all this. Yeah, we don't want to see that. Now, which mixture could be best separated using a separating funnel? Now, what is a separating funnel? Yeah, funnel, like it's going to be like this. It's a funnel. Yeah, but okay, if you have, okay, two, let's say for example, there are two layers. Okay, one example that I can give you, if you have oil and then you have water. Okay, oil is going to be, density of oil is going to be lower than water. They will, over time, they will give you two layers. So what we can do, okay, there is going to be like a tap over here. You can actually open the tap and remove the water and keep the oil at the top. So you can separate that way. Yeah. So you can do that if they are not mixed with each other. Yeah, that is the entire idea. So if I have oil and sand, okay, oil and sand, how do you going to, because it must be two liquids. Yeah, separating funnel, oil and sand. Oil is going to be really mixed with sand. How do you separate? Yeah, cannot. Okay, sodium chloride and sand also, you cannot actually separate just like that. Okay, so if you have oil and water, yeah, you see oil and water is the best solution. Okay, sodium chloride and water, they are mixed together very well. How to separate them just like using separating funnel? No, yeah. So do remember, okay, we have to use, okay, in this case, oil and water. Okay, so if it is sodium chloride and sand, we have to use, okay, filtration method. Okay, filtration method is different than separating funnel. Yeah, please remember that. Now, if let's say, okay, if I have, let's say for example, I have a beaker and then I have sand over here and then I have water. Okay, like we have over here. Let's say for example water, and then I try to pour them. Okay, so that I try to not to remove sand. I try to pour them over there. What method is this known? This is a separating method as well. Elvina, what is this method called? Where you get only water, leaving sand behind. Don't know, just say don't know. I'll pass it to someone else. Naomi?
Sir.
Again?
Is it safety?
It starts with D, ends with N.
I don't know, sir.
Gianna?
Distillation.
No. Distillation was just now, yeah? So this one is...
I thought this is
No. Jesse, want to try?
distillation.
No. Decantation. Yeah. So it's called decantation. Decantation is a very simple method. Yeah. You have you let it stand for a while, and then you have the sand, and then you want to remove the water. You just remove the water. Just slowly remove it. So it's not going to be 100% efficient, but this method is also a method of separation. So it's called decantation. Yeah. Guys, give me a moment. Yeah. I need to reply this for all. Okay, let's continue. So here, if I have, hold on. Now, so that is decantation, yeah. That is decantation. So let's actually move on to question number 10. Now, a compound X, has a melting point, of 71, boiling point 375. Which one is correct? So this one, let's actually look at one by one. Yeah, it is at 52. At 52 means they have not reached melting point. So it must be solid. Yeah, so this is wrong. At 69, haven't reached melting point. So still should be solid. It is liquid at 75. Yes, already melted. Correct. Gas at 350. Wrong, because haven't reached boiling point yet. Yeah. So still liquid. It's a liquid at 80. Correct. A gas at 400. Already reached boiling point. Must be gas. So the answer is going to be D. Yeah. So just take note of that. So next question, so Jensen, get ready for this question, Now, so the results shown by the chromatogram are shown, the distance traveled, by the solvent, and then the distance traveled by substance X, substance Y given. Which row gives you the RF value for substance X and substance Y? So do remember, the formula. The formula for this is going to be RF. For X and Y, for X, the distance traveled by X3 divided by the total distance traveled over here, which is 5. And then for Y, is going to be the distance traveled by Y divided by distance traveled by the solvent, which is going to be 5. So Jensen, can you tell me what will be the value for X?
0.6.
0.6. This is going to be
0.5.
0.5. So you just need to go and check. 0.6, 0.5, and that's going to be the answer for B. So please take note of this. Now, the diagram shows the liquid in burette and a measuring cylinder. So do remember, yeah, okay, in burette, okay, everything, okay, must be measured at the bottom of the meniscus. Unless we are talking about mercury. Mercury will be like this. So we measure at the top. Okay, but most of the time, okay, in our chemistry, we are dealing with anything to do with solution. Yeah, so definitely they are going to be, the meniscus will be something like this. So we measure at the bottom, yeah, not at the top, yeah, at the bottom. So here, okay, they say it shows the liquid in burette. So if you have, okay, if this is 28, you can see 28, this is 27, okay. So what is going to be the burette reading? Yeah, so this one can be confusing. Okay, burette reading, what is going to be the burette reading? Are you going to actually measure this one as 27.1, 2, 3, 4, 5, 6, 7, 8? Or are you going to say, oh no sir, this one 28 must be 28.12, 28.2. Which one do you think will be the correct version? Yeah, so maybe Brian, you want to try?
The measuring cylinder is 44.
Measuring cylinder is 44, okay, correct. Okay, measuring cylinder no issue, yeah, because it starts from 0, yeah, over here. So it actually from 0 to 44, okay, that is no issues, yeah. Then
The
burette 27.8 or 28.2?
27.8.
Yes, yeah, please remember the 0 for burette starts at the top. Okay, 0 from the burette starts at the top. You measure from there. Okay, so you measure from there. So it means this is going to be 27.5, 27.8. You don't just say because of this I'm going to use that. No, yeah. So it starts from 0 at the top, then all the way down. Okay, so 27.8. Okay, and then 44. Okay, please remember this. Yeah, very important. Now 13. Okay, so Kayla, ionic bond is formed between what? Electron sharing or transfer? Hurry up, hurry up. No response. Kimberly, ionic bond is formed by electron sharing or transfer?
D.
D. So straight away you give the answer. So transfer, yes. So electron transfer. So it can be C or D, yeah. So ionic bond must be metal to non-metal, yeah. So the answer is going to be D, yeah. What changes when an ion is made from an atom? Okay, so do remember the only thing that will change, okay, when it forms ion is the number of electrons. Whether the electron become more. When they are more, negative ion. When they become less, then they become positive ion. So the one that will change is only electrons only, yeah. Please remember this, yeah. So the next question, yeah, so maybe this one, Max, okay, answer this, yeah. Max, in the diagram below, circles of different sizes represent atom of different element. Which one represents a mixture, argon and nitrogen? Mixture, yeah. Argon and nitrogen.
B.
B. Why B? Why you choose B?
Because mixture.
Okay, you are almost there. Yeah, it's almost there. This one is compound, so you didn't choose. But be careful next time, yeah, Max. So because argon, okay, is group 18, so it's a monoatomic gas. But nitrogen gas is going to be diatomic N2. Yeah. So you do not actually take it as 1. Okay, the better answer will be D, Max. Is that clear, Max?
Yes.
Yeah, so this is argon. This will represent for nitrogen, diatomic. Yeah, so it's a mixture. Yeah. So the answer is going to be D. So just be careful next time. Yeah. Now number 16, the electronic configuration of ion. Yeah, ion. Yeah. So it's 288. What could this be? Okay, sulfur. Okay, sulfur is 16. Calcium is going to be 20. So let me write down first 28. Okay, 6, 2, 8, 8, 2. Okay, so if it is going to be ion, okay, it means they can lose the 2 electrons. So Ca2 plus. So they lose 2 electrons, they become 2.8.8. Okay, this one will gain 2 electrons. Okay, so they will give you S2 minus 2.8.8. So you see, both also can have the same. Okay, so S2 minus Ca2 plus, both also can have the same. So the answer is going to be A. Okay, now next question. Okay, 2 elements, okay, represented by given here, forms either mixture or compound. Which diagram shows a pure substance of element? Okay, pure substance of element. Okay, so this one maybe because it's similar also, I'll ask Max to answer this. Yeah, so which one is going to be pure substance of element, Max? Element means, okay, there is no mixture. Yeah, so it means it must be only one. Okay, so which one, Max?
D.
No. Okay, I just gave you the hint just now. Element means they should not be mixture, should not be a compound. Must be one single element. Okay, one single element. You see, this one is actually one, and then one they already a mixture. Okay, this one they are already a compound. Okay, different element already compound. This one is a mixture. Okay, it's a mixture like what we did just now. So the one that is going to be pure substance of element is going to be this B, because okay, maybe this one is nitrogen and another nitrogen, so N2 only. Okay, N2 and N2, N2 and N2, so it's only element of N2. Okay, so that is going to be element. Okay, so please understand this. Okay, very very important. Even though this one is going to be element, but they are mixture. Okay, they are not pure. Yeah, they are not pure. So in this case, this is going to be pure substance. Okay, now 18. A paper chromatography experiment is carried out to separate and identify the mixture of amino acid produced from the hydrolysis of protein. Now, do remember, for protein is colorless. And in order to see, okay, you must use an agent, a chemical, which is going to be called locating agent. Okay, so if you are wondering what is a locating agent, okay, so it means that you need to, okay, locating agent means, okay, you need to use the chemical, okay, to locate or to indicate, okay, the compound, yeah, the protein. So in this case, which apparatus is needed? Yes, you need chromatography paper, you need locating agent, okay, but what else do you need? Okay, so you cannot use marker pen. Okay, why you cannot use marker pen, Dave? Dave, are you there? Why cannot use marker pen?
Sorry?
Why cannot use marker pen for chromatography?
Because it might dissolve.
Yes. Yeah. Do you need thermometer, Henrietta? Okay, you are not measuring temperature, you do not need thermometer, you need solvent, you need pencil, you need ruler for the RF value and so on. So the answer is going to be B. Yeah. Now, how many different elements are present in copper sulfate? Yeah, elements. Yeah. So you see, this is one element, copper. Sulfur is one element. Oxygen is one element. Hydrogen is one element. and then oxygen is the same element. So you see how many different elements that are present over here. There are total of 4 different elements. Yeah, 4 different elements over there. So the answer is going to be C. Yeah. The next question is going to be 20. Which of the following is correct example of element, compound, and mixture? Yeah. So element, I told you element means doesn't have any mixture. You see, air is not element. Air is a mixture of many gases. Nitrogen, oxygen, hydrogen, so many. So it's not going to be element. Tap water is not element also. It contains water. Water is already compound, and it's actually a mixture. There's a lot of minerals inside. Copper, on the other hand, is an element. Only copper, Cu atoms are there. And then compound. You see compound, silicon 4 oxide. Is a mixture of 2 elements or more elements chemically. Cannot be separated easily. So silicon 4 oxide is going to be an answer, and then tap water I just mentioned to you is a mixture. It's a mixture. So this is going to be C. 21. Which of the following radioisotopes is used to treat cancer? This one you check again. I'm not so sure, but if I'm not mistaken, it's supposed to be iodine 131. So this one, please check. Please check. This is going to be cobalt 20, technetium no, carbon 14 no, cobalt 60. I'm not sure, but I think iodine. Iodine 131. But we will come back to this. If it is wrong, then I will come back to you. I'll inform you. Now, number 22. 2 elements have the following property. Ductile. Ductile means you are able to pull the element. You are going to pull the element so that it can become a long wire. Without breaking. Malleable means you can hit them and make sure that the shape is going to be changed. Sonorous. This one, go and find out what is the meaning of sonorous. Find out. And then conduct heat as well. Which of these element could be? So do remember this one, ductile and malleable is going to be more towards metal. And then conduct heat well must be metal that should be able to conduct heat very well. So if you have iodine, iodine is going to be a covalent compound. Cannot be. So cannot be iodine. Silicon is also going to be non-metal. How do I know all this? You look at your periodic table. So cannot be. Carbon. Carbon and nickel. Let's wait for a while. Carbon and nickel, but strontium and rubidium. Let's actually look at strontium and rubidium. So let's actually look at the periodic table. Strontium and rubidium. You guys, if you have your periodic table, you look. I will just look over my own periodic table. Strontium and rubidium. Strontium is going to be group 2. Rubidium is, where is rubidium? RB. Anyone found where is RB? Why I cannot find now? RB, yes, RB is group 1. RB is group 1. So you see, rubidium is group 1. Strontium is going to be group 2. So both of these, are going to be group 1 and group 2, but they are supposed to be soft metal. They supposed to be soft metal, especially I think when it comes to group 1. Rubidium is soft metal. Carbon, malleable. Ductile, malleable. I don't think so. Carbon is going to be ductile, malleable. Nickel, yes, possible. Conduct heat. Carbon also can conduct heat. Okay, I think the best answer for now, yeah, I will actually select C, yeah, because both of them are metal, yeah, group 1 and group 2. Okay, but I know that group 1, okay, is a soft metal. Okay, don't know whether, okay, it's ductile and malleable or not, but generally metals are ductile and malleable, yeah. Okay, but carbon, okay, I don't think so. Carbon is that ductile. I don't think so. Carbon is that malleable as well, yeah. So anyways, okay, the answer is going to be C. Again, if there is any mistake, okay, I will come back to you again. Yeah, 22. Now, 23. Which electronic structure represents the electron arrangement for fluoride ion? Now, fluoride is going to be 9. Yeah. So 2, 8, okay, 2, 7. Okay, 2, 7. So if F minus, it means they are going to be 2, 8. Yeah. So they receive 1 electron. So they will have 8 electrons at the outermost shell. Okay, so definitely not this. Okay, possible. Okay, 2, 8. Okay, cannot. Okay, 2, not enough. Okay, this is F only. So the answer is going to be B. Okay, 2, 8. Okay, fluoride ion. Now, next question 24. Which of the following is true about iron 2 and iron 3? Okay, iron 2 and iron 3. They have the same number of electrons. Okay, they have same number of electrons. They have same number of proton. Okay, they form, okay, the iron atom by losing same number of electrons. They are formed from iron atom by losing the same number of electrons. No. Okay, from iron atom by losing, this one losing 2 electrons, this one losing 3 electrons. So D is definitely wrong. Okay, and then Fe, okay, do remember ion, yeah, ion can have different number of electrons. So this one, okay, definitely wrong. Okay, different number of electrons, okay, but okay, they will have the same number of proton. Okay, proton will not change. Okay, will not change. Then the compounds they form have the same chemical formula, definitely no. FeCl minus, so Fe2 plus Cl minus, so they will form FeCl2. Fe3 plus Cl minus times 3, so FeCl3. They have different chemical formula. Okay, so the answer is going to be C. Okay, next. Okay, so here, okay, I think this one Cheryl can help to answer. Okay, Cheryl, can you tell me which of the two particles belongs to the same element? How do you identify they belong to the same element?
Oh, same number of proton.
Same number of proton, good. Yeah, so these two, you can see 2 and 3, they have same number of proton. Doesn't matter about the electron. Yeah, they say same element, it means they must have the same proton. So it means that, okay, element 2 and 3. So that's going to be the answer. Okay, let's move on. 26. Okay, the formula of compound W, X and Y are shown below. Okay, which statement is correct? Okay, so W contains twice as many hydrogen atoms. How many hydrogen atoms that W has here? It has 10 hydrogen. Okay, 5 times 2, yeah, 10 hydrogen. As many hydrogen atom as oxygen atom. Let's actually look at oxygen atom. 5 oxygen and 4 oxygen. 9 oxygen. Okay, so 9 oxygen, and that doesn't make sense. Yeah, so this one wrong. X contains the most oxygen atom. Let's count. Yeah, 7 oxygen and 4, 11 oxygen. This one 6, 2 times 3, 6 oxygen, 6 oxygen, 12 oxygen. Y is supposed to be containing the most oxygen atom, so wrong. Y contains the most hydrogen atom. Let's count. Yeah, 10 hydrogen, so 14 hydrogen. Okay, this one is going to be 6 times 2, 12 hydrogen. No, X supposed to be the most hydrogen atom. Y contains the same number of hydrogen and oxygen atom. Yeah, so Y, you can see, contain the same. So that is going to be our answer. Okay, D. Now 27. Which row correctly describes the oxides? Okay, This one we haven't learned, yeah, so we can skip, yeah. But anyway, okay, I'll just give you the answer, yeah. Amphoteric, okay, this is amphoteric, okay. This one is going to be K2 is going to be, we call it as group 1 and group 2, we call it alkaline metal, so they are going to be basic. Okay, so this one is also group 2, so alkaline metal, and then non-metals will be acidic. Yeah, but don't worry, okay, there is a change of syllabus, they are no longer in your MYE this time. Yeah. Now 28. So they are giving you the ability of 4 substances to conduct electricity. Okay, so W does not conduct electricity at any condition, must be anything that is non-metal. Yeah, so W must be non-metal. PB is metal. Yeah, if you are not sure, just look at your periodic table. Yeah, PB is metal. Okay, so in this case, this can be the answer, this one cannot be the answer. Let's look at X. Conducts only in aqueous solution. Yes, okay, all these, okay, can conduct electricity in aqueous solution. Yeah. So then, okay, conducts when molten and also in solid. Okay, now in molten can, but in solid sodium chloride cannot. Okay, I told you last time, ionic compound, okay, they do not conduct electricity and in powder form, in the solid form. Yeah, so now, okay, if you are looking at conduct in molten and solid, yeah, must be something like metal. Yeah, so this one, okay, in solid HCl also do not conduct. Yeah, and then conduct in molten and aqueous solution. So ionic when they are molten, yes, they conduct electricity. Okay, and then in aqueous solution, free moving ion, they conduct also. Yeah, so the answer is going to be C. 29. The diagram shows an outline of a part of the periodic table. Okay, which one of the following is not correct? Okay, X, okay, Y and Z. Yeah, if you look over here, this is group 1, group 2, this one is transition element. Yeah, so it means they are all metal. Correct, they are all metal. All conduct electricity. Okay, all conduct electricity, there is no issue with that. Okay, all form colored compound, no, only Z, okay, forms colored compound, the transition metal. Okay, all react with oxygen, yes, all can react with oxygen, but the answer is going to be C. Yeah, so for 30, okay, all right, is this your lunch time, guys?
We have maths now.
Okay, you have maths now. Yeah, okay, let me finish at question 30. Yeah, so the element in group of periodic table shows the following trend. Okay, so all the element with lowest proton, okay, has the lowest reactivity. Okay, it means that the one on top, okay, is lowest reactivity. Going down, they become more reactive. Okay, so this one I think is like something like group 1. Yeah, and then they form basic oxide. Yeah, must be metal. Yeah, so the alkaline metal density increases down the group. This one, remember I told you, okay, density, the mass will increase, of course the density will increase. The melting point, okay, decreases, okay, down the group, because I told you they are getting bigger and bigger. The electron and the metal cation, the distance is getting bigger and bigger, so melting point is going to be decreasing. So this one, the best answer is going to be A. Yeah, so the next question over here is, okay, fluorine is at the top of group 7 in the periodic table. Okay, so which row shows the properties of fluorine? Okay, so what is the color of fluorine? Okay, it's yellowish or green yellow color. Yeah, so something similar to chlorine. Yeah, so green yellow, but definitely not brown. Okay, definitely not brown, because brown is more towards okay, I think brown, okay, is more towards iodine. Okay, when they are in liquid color, or maybe bromine. Okay, bromine when they are in aqueous is brown. Okay, but definitely yellow. So is it going to be gas or liquid? Yeah, so do remember FCBI. Okay, this is gas, this is gas, this is going to be liquid, this is going to be solid. Okay, why? Because as you go down the group, okay, the boiling point, okay, the boiling point becomes decrease. Okay, boiling point becomes more, sorry. So the boiling point is increased. Okay, because of that, okay, they are going to be becoming from gas to become solid. Gas to solid, because very high boiling point, they cannot change into liquid, okay, or gas. Okay, so the iodine will stay as solid. So in this case, okay, the state at room temperature for fluorine is going to be gas, not liquid. Okay, the one liquid is going to be Br. And then the reaction with aqueous potassium iodide. Yeah, so you see here, F2 with Ki. Okay, now I want to know which one is more reactive, F or I? Max? Exam is coming on, yeah, so you need to know which one all this, yeah. Okay, I recall again. Okay, so group 1, when we are talking about reactivity, group 1, ability to lose electron. Okay, to lose electron, the size getting bigger and bigger, electron easier to be lost, therefore going down, reactivity increases. Okay, now this is group 7. Okay, group 7, size is getting bigger and bigger, but they want to attract electron, because 7 valence electron, they need to bring in 1 electron. It's going to be difficult to bring 1 more electron in at the lower part, because the attraction of the nucleus is weaker. Okay, so going down, the reactivity decreases. Okay, reactivity decreases. So now it means that the one on top is more reactive than the one below. Yeah, so Max, using this kind of explanation, yeah, so F2, more reactive or less reactive? More reactive. They are more reactive than I. Okay, it means that they are more handsome than this boyfriend. Okay, so what will happen? Okay, the relationship will be broken. Okay, once this relationship is broken, this is what we call a displacement. They are going to be K will join with F, and then the I will be left alone to cry. Okay, so that is going to be what is going to happen. So in this case, okay, what do we call it? Iodine is displaced. Okay, displacement do happen. So the answer is C. Okay, remember this, yeah. Okay, we have learned about this. I even taught you about how to remember density, yeah. Please remember all this, yeah. So group 1, okay, let's actually recall this as well. Okay, going down group 1, reactivity increases. What can you say about density, Henrietta? Increases or decreases density?
It decreases.
Decreases, yeah. No. Okay, do you think it decreases? Increases. Both of them increases. Why? Because I told you, as you go down, the mass increases. If the mass is increasing, okay, of course, okay, the density is going to be mass divided by volume. Okay, if mass divided by volume, it means the mass is increasing a lot. Yeah. Compared to the volume, even the volume is actually is increasing, but the mass increases a lot. Okay, so density for both will increase. Okay, please remember that. Easy to remember. Now, another thing is to talk about this melting point. Okay, melting point, both of them. Yeah, so melting point for this metal, I told you to remember. Metal, they will form metallic bonding. So metallic bonding is the bonding between metal cation and the C of delocalized electron. So if you, let's say, all these forms positive, and then the electron, you see electron, electron, electron. You see the electron, the gap, the distance is smaller compared to the distance over here. It means that as you go down, okay, there is bigger gap, okay, between the metal cation and the sea of delocalized electron. If you have bigger gap, okay, it means the bonding is not that strong. Yeah. So because the bonding is not strong, the melting point decreases down the group. Yeah. Because it's related to this metallic bonding. Okay. But when it comes to, okay, I told you to remember one. If this one is less, this one will be more. Okay. Why? Because just now only I mentioned to you. Okay. The boiling point increases. Yeah. Why? From gas to become solid. The same, if boiling point increases, the melting point also increases. Why? Because, okay, because they are getting bigger and bigger. Okay, when they get bigger and bigger, more electrons. If they have more electrons, okay, if you have, okay, another molecule, if you have, okay, let's say, okay, I draw first. Okay, let's say Br2, okay, Br2 with another molecule of Br2. With another molecule of Br2, because they have a lot of electron, okay, they are going to have greater attraction, okay, between these two molecules. Yeah, so maybe more negative here, more positive here, more attraction. Yeah, because of that. So do remember, bigger the size, okay, for group 7. Yeah, because group 7 always form F2, Cl2, Br2, I2. Okay, but there is one element in group 7 do not form diatomic molecule. Can you remember which one? Jocelyn? Naomi?
Yes, sir.
There is one element in group 7 that do not form diatomic. Do you remember?
It's astatine.
Yes, it is astatine. Yeah, so the one that comes after that, after I, okay, astatine do not form diatomic. Okay, but again, okay, the rest all forms diatomic. Okay, they are going to have, okay, high boiling point, high melting point. So in summary, yeah, okay, I want you to remember this. Okay, in summary, in simple terms, if you have group 1 or group 2 and then group 7, yeah. In summary, what I want you to remember, reactivity going down, yeah, all this reactivity. Okay, if I bring this a bit over here, cannot see. Okay, if I put the reactivity, okay, bring it over here. Okay, if I'm talking about reactivity, and then I'm talking about melting point, and then another one that we talk about density, I just want you to remember, going down, reactivity increases, reactivity decreases. Okay, and then related to density, okay, you need to remember, okay, both of them, okay, the mass is increasing, okay, so density increases. Melting point, okay, because group 1 is going to be metal, okay, metallic bonding, okay, the size is getting bigger, the metal cation, so less bonding, yeah, between the metal cation and the electron, delocalized electron, so the melting point becomes less. But the other way around for, okay, group 7, okay, melting point is going to be more. Yeah, so these are the things that I want you to memorize. Yeah, so make sure you remember this. Okay, now 32. The diagram shows the structure of two forms of carbon. Okay, so two forms of carbon, there is a word for this. Okay, different formation of carbon, same element, different arrangement. So it starts with letter A. Okay, can someone help me to tell me what is this?
Diamond.
Diamond, no. Jessie?
Allotropes.
Yes, okay, they are called allotropes. Okay, allotropes means, okay, the same element have different arrangement. So here, okay, this one is of course diamond, okay, and this one is going to be graphite. Okay, apart from diamond and graphite, there is one more, allotrope of carbon that I taught you. So can you tell me what is the one more, Elvina? Try. If you don't know, just say pass. Don't know. Yeah. So maybe Michelle Angsono. Pass. Okay. Oh, Jesse, you know or not? Silicon dioxide, no. Naomi, not silicon dioxide. Silicon dioxide is another, because allotropes, I'm talking about allotropes of carbon. Yeah, silicon dioxide, yes, they are going to be the giant molecule. Yeah, SiO2. Okay, but again, let's actually try. Just now, who wanted to answer? Jesse, try. Fullerenes, yeah, correct. Okay, the fullerenes, okay, this one I told you, Buckminster fullerene, okay, is going to be another form of allotropes, but they are not giant, yeah. Okay, they are going to be considered to be 60, yeah, 60 atoms, so it's simple molecule. So anyways, okay, now let's say which data is correct of these two structure. You see here, one atom of carbon bonded to 3 atoms of carbon. Okay, it must be totally, a total for carbon must have 4 hands. Yeah, if you have 3 hands, it means there are going to be 4 electrons, valence electrons, so one of the electron will remain. So this electron that will remain, each one will have 1 electron. They will be able to conduct electricity. So which one can conduct electricity? Definitely S can conduct electricity. Okay, T cannot conduct electricity. You can see each one atom is bonded to 4. Okay, all the electrons are being used up. All the 4 valence electrons are being used up because carbon is going to be group 4. Yeah, 4 valence electron is used up. So cannot, diamond do not conduct electricity. Very hard material. Yes, this is very soft. Okay, and this is T is very hard material. Can be used as lubricant, graphite. Yeah, because they can slide. Okay, the layers. Okay, the forces between here and here is weak. So the layers can slide on top of each other. Yeah, so that is going to make it to be suitable to be used as lubricant. Now, next, okay, which statements are true about all the noble gases? Noble gases are going to be group 8. So all, yeah. So they are telling the number of proton in their atom equals to the number of neutron. Yeah, should not be. Yeah, if you are not sure, also you just check. Okay, neon. Okay, neon is 10. Okay, you can just double check. Okay, let's see. Okay, you see the difference 2, the difference 10, the difference 22. So they are not the same. Okay, the neutron is not the same as the proton. Yeah, this is the number of proton, not the same. Okay, so definitely the first statement is wrong. Okay, so first statement is wrong. So of course these two are wrong. The number of proton, okay, in the atom do not equal to the number of electron. Wrong. Okay, proton must be the same as electron. Okay, so number 2 is also wrong. Okay, they all have 8 electrons in the outer shell. Okay, all have 8 electrons. Actually, okay, this one is contradicting a bit. Okay, not all of them have 8 electrons in the outer shell. Okay, because helium. Okay, helium is 2 electrons only in the outer shell. Duplet. Okay, so not all of them. They do not react to form any compounds. Yeah. Okay, so the answer is 4 only. Okay, noble gases, they already have octet structure. Okay, they do not need to react. They cannot react. Okay, 34. Carbon dioxide is a covalent molecule. Okay, which contains bonding and non-bonding electrons. Okay, let's see. Yeah, carbon dioxide. I already taught you how to draw carbon dioxide. So carbon. Okay, oxygen. Oxygen. Okay, Carbon has 4 valence electron, group 4. Okay, so 4 valence electron, they need another 4. Yeah, they need another 4. So what they do, okay, they need like for example carbon, they need another 4. Oxygen, okay, oxygen, they are going to be group 6. They need 2. Yeah, so they get 2 from carbon. So oxygen take 2 from carbon, another oxygen take another 2. Okay, so in order to get that 2, okay, it means oxygen also need to give 2. So what I'm going to do, okay, carbon, okay, share with oxygen. Okay, so carbon share with oxygen. Okay, carbon already 4. Okay, then they share. Now they have 8 complete. But oxygen, they are group 6. Yeah, so 1, 2. Okay, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay, so if you look at oxygen now, they already have 8. Yeah. So now to answer the question, how many pair, okay, of non-bonding, okay, non-bonding, yeah, these are the bonded electrons. Okay, non-bonded electron, non-bonded, 1, 2, 3, 4. But they say how many pair, yeah, okay, not electron, how many pair? Okay, 1 pair, 2 pair, 3 pair, 4 pair. Okay, 4. Okay, the answer is 4. 35. Element X, Y, and Z are in group 7 of the periodic table. Okay, and then they say X is a gas. Yeah, you see, if they say X is gas, X must be at the top of the periodic table. Why? Because I told you it starts from gas, liquid, solid. Okay, so then they say Y is less reactive than Z. Okay, so it means I know that the one on top is more reactive. Okay, so if Y is less reactive means it must be Z comes first, then followed by Y. This one I know. Yeah. Then Z is a red liquid. Z is liquid. So if Z is liquid, X was gas, so automatically this one will come on top. Automatically X will come at the top because X is a gas. Okay, they say this one is liquid, and then Z is more reactive than Y. Okay, so when X, Y, and Z are put in an order of increasing proton number. Okay, increasing proton number. Of course, this one is lower proton number followed by higher proton number when you go down the periodic table. Yeah, the group. Okay, when you go down the group. Okay, so of course you are going to have, okay, increasing proton number. So which order is correct? So it should be X followed by Y, X followed by Z followed by Y. Okay, so the answer is B. Okay, next.
Wait, sir, what's the answer for 34?
34, boy.
Okay, thanks, sir.
Yeah, because they're asking for pair, yeah, not electrons. Be careful with that. If they say how many electrons are non-bonding electrons, then your answer will be 8. Yeah, in this case. Okay, just I hope you understand all these 35 questions. Yeah. So now, okay, let's actually go for our structured question over here. Okay, so here, okay, substance X can undergo the following physical changes. Okay, so give the correct name for each of the numbered physical changes. Yeah. So number 1, solid to become liquid. Yeah. So Albert.
Melting.
Okay, good, melting. So number 2, okay, Jensen.
Condensation.
Yeah, condensation. Gianna, number 3. Liquid to solid. What happened to Gianna? Okay, Kimberly, what happened? Can you tell me number 3?
Freezing.
Freezing. Okay, Gianna is here. Gianna, what happened to you? Hold on, yeah. Gianna, can you hear me?
Yeah, I was lacking. So
Okay,
I
okay.
wasn't able to.
Okay. Now, how about number 4, Gianna? Solid to become gas. Sublimation, yeah? Right. Now, explain, okay, why the changes shown are physical changes. Yeah, so why these changes are known as physical changes? Kimberly? Why this one is physical change? They are not called as chemical change.
Because they are reversible.
Yeah, rather than reversible, it means they can rather than saying that they are reversible, you say that they can be converted to each other. Yeah, let me see the marking key first. Yeah. I don't have the marking key now. Okay, I'll check again. Yeah, but again, okay, why the changes are shown are physical changes? Because the changes are, okay, we will put it as the changes are reversible. Yeah, okay, the changes are reversible, but it's not actually, the term reversible is not suitable. The changes, okay, once you change into solid, you can change back to gas or something like that. So the changes are let's keep it as reversible first. Yeah, okay, the changes are reversible. I'll check for you now. So in which state do the particle X have the least energy? Okay, so least energy means they do not have a lot of movement. Yeah, they do not have a lot of movement. So is it going to be in gaseous state, liquid state, or solid state? Naomi?
Solid.
Okay, solid. Yeah, the part that they do not move a lot. Yeah, so solid. Now, which two of these changes of state occur when the energy is absorbed? So, energy is absorbed, it means they are going to be moving more. Okay, distance gets between the particles gets more. Yeah. So, which changes occur when energy is absorbed? Okay, so you see, is melting the answer? Which two of these changes of state, okay, occur when energy is absorbed? So maybe they are talking about the number, yeah, number 1, number 2, number 3, and number 4. Okay, energy absorbed. Okay, so I just want to check. Okay, so let's say Cheryl, number 1, solid to liquid, energy absorbed or not?
energy loss.
Loss, yeah. Solid to become liquid. Energy absorbed, yeah. Energy absorbed, yeah. So then only they can move more, then they change into liquid. Energy absorbed, okay. But liquid to solid, definitely they will lose the energy, yeah. They will lose the energy. Now, gases to liquid, okay, they are also losing the energy, okay. But solid to gas, yes, they absorb the energy. So you can either put 1 and 4, okay, 1 and 4, or you can write down number 1 is melting, so you just say melting and sublimation, and explain, okay, using your ideas about forces between particles. So you just say energy is absorbed, okay, to break
Sir, why
mm.
why cannot use boiling also?
Yeah, but they say this, yeah. Okay, so they say this, yeah. So there is boiling, yeah. So if you want to write boiling or evaporation, should not be a problem, yeah. Should not be the problem, because they also mention it over here. So if you want to write down boiling, also still possible. Boiling or evaporation also can. Okay, no problem. Okay, so the energy is absorbed to break the forces of attraction between the particles. Okay, so they get further away from them, yeah. Now, one difference between boiling and evaporation is the temperature at which the process occurs. State another one difference between boiling and evaporation. So you see, boiling happens at boiling point, yeah. So evaporation can happen at any temperature. So another difference between boiling and evaporation. So this one, maybe Jake, can you try to answer?
During boiling, there's bubbles.
Actually, that is not the suitable answer, yeah. So that is observation, yeah. We don't want to see observation over here. So difference, okay, I told you, okay, the main difference, okay, between boiling and evaporation. Boiling happens throughout the liquid, yeah, throughout the liquid. But evaporation, okay, I gave you this example of drying your clothes, okay. If you fold and you dry them, only the part that is facing the sunlight will dry, yeah. The one in the inner side will not dry properly. So it means that boiling happens throughout the liquid, evaporation happens at the surface of the liquid, yeah. So that is another difference, okay. Boiling happens throughout the liquid, but evaporation happens at the surface of the liquid. Okay, so this is going to be another difference, yeah. Now, next, kinetic particle theory explains the property of matter in terms of arrangement and movement of particles. Compare the arrangement and distance. Compare the arrangement, distance, and movement, yeah, of the particles in solid state of element to those in gaseous state, yeah. So we want to talk about gaseous state. Okay, so solid you want to compare to gaseous state. Okay, so arrangement of particle. Okay, regular, okay, regular and compact arrangement, okay, regular and compact arrangement, comparison compared to gaseous state. Distance between particle, okay, the distance between particle. So there are very minimal distance, yeah. So very just say very small distance, okay, compared to large distance in gaseous state. Movement of the particle, okay. So when it comes to movement, okay, solid only vibrate, okay, they only vibrate in a fixed position. And gases can vibrate, rotate, and move from one place to another. Okay, so these are the explanation that you need to give. Yeah, 10 marks. Okay, done. Now next, okay, ammonia gas is produced when aqueous ammonium hydroxide is warmed with ammonium sulfate. Okay, ammonia, they give you this statement: ammonia is less dense than air, okay, and very soluble in water. Okay, the apparatus shown below was used to prepare a sample of dry ammonia gas. Yeah. So number 1, okay, complete the box to name the apparatus. Okay, number 1, number 2, and number 3. Okay, we want to name the apparatus. Okay, so this one, okay, hold on, yeah. Okay, this one I'll try to get the marking key, hold on. Okay, but while waiting, number 2, I think someone can actually give us the answer. Okay, what is number 2? Jesse?
Gas jar.
Again?
Gas jar.
Gas jar. Okay. Let's see, yeah, because this one we want to confirm the answer given. Yeah, so number 3 is like a called delivery tube also. Okay, but let's look at the answer. Hold on. Okay, number 2. Okay, yes. Okay, number 2 is confirmed, gas jar. Okay, number 3, okay, is delivery tube. Okay, cannot be glass tube, yeah, delivery tube. Okay, number 1, okay, this one is not burette, yeah. So this one is called thistle funnel. Okay, thistle funnel, or they call it separating funnel. Okay, but definitely not burette. Okay, definitely not burette. Okay, while I have the answers, let's actually check this one, number 1B. Hold on. Number 1B, okay. Yeah, the answer is the change can be reversed, no new substances are made. Okay, so rather than reversible, I think better just say the changes can be reversed. Okay, don't use reversible. Okay, because reversible has different meaning in chemistry. Okay, the changes, okay, are can be reversed. Okay, the changes can be reversed. No new products are being made. Yeah, no new products are being made. Okay, let's see any numbers that I circle. Yeah, hold on, yeah, 21 and 22. Let's check the answer also. 21 is A and C. So I'm wrong over here, yeah. Okay, 21. Okay, please check. Yeah, the answer is going to be cobalt 60, not iodine 131. Okay, answer is cobalt 60. Okay, just make changes here. The rest should be okay. I think this one, why I put this one, no problem. Okay, only that. Yeah, the rest all okay. Yeah. Now let's move on. Okay, complete the boxes. So the boxes are already completed. Now, what necessary piece of equipment, okay, is missing in the diagram according to the information given in the question? Information given in the question, okay, are given, but one piece of equipment is missing. So Naomi, can you actually identify one piece of equipment that is missing over here?
Bunsen burner.
Yes. Why? Because it is being warmed over there. So Bunsen burner is missing. Okay, Bunsen burner is missing. Now, there is another one mistake in the apparatus. Identify and explain the cause of this mistake. Okay, so another one more mistake over here. Okay, what is the mistake? Okay, I think you should be able to get the answer based on my highlight over here. Yeah, let's see. This one. Less dense than air. Okay, so who wants to try? Maybe I'll just ask Terence. Can you try? Hurry up.
Not sure, sir.
Because they say it's less dense than air. What kind of method that you are using to collect the gas? Upward method or downward method? In this case, in the diagram, you are using upward method. Okay, so it's less dense, so it's still okay. I think still okay. Yeah, ammonia is less dense than air and very soluble in water. Okay, then still okay. What else is the problem over here? Diesel funnel you put, okay, then you put everything, they go directly to the delivery tube. Yeah, Jessie? Yeah, Jessie?
You say next time the ammonia can make reaction with the concentrated sulfuric acid.
Yes, yeah. So that is the error over there, yeah. Because okay, this one is actually the collection is still okay. Yeah, collection is still okay. It's less dense than air. So you are drying the gas, okay, using the concentrated sulfuric acid. So if you are using ammonia, okay, you cannot use concentrated sulfuric acid because ammonia reacts with concentrated sulfuric acid. Yeah, so that you cannot use, okay, concentrated sulfuric acid. Yeah, so you check under, okay, methods of drying gases. Yeah, okay, how do you dry gases? Okay, so in this case, okay, state another one more mistake. Okay, let me check my previous notes. Yeah, I think let me show you. Okay, drying of gases, you check. Okay, you see here. Okay, if you have, okay, concentrated sulfuric acid, okay, you can use for all except for ammonia. Yeah, why? They will react with ammonia. Okay, you can use calcium chloride also, okay, but also cannot use for ammonia, calcium chloride. So the best, okay, is actually you're supposed to use quicklime, yeah, which is calcium oxide for ammonia. Yeah, So for ammonia, we use calcium oxide to dry. Yeah. So you cannot use calcium chloride. Okay, you cannot use sulfuric acid. Okay. So the mistake using concentrated H2SO4 in exam write in full, yeah, to dry the gas, the ammonia gas. So explanation, okay, ammonia gas will react with concentrated H2SO4. Okay. Now name the method by which ammonia gas is collected. Just now I think I already mentioned the method. So upward delivery or downward delivery. Again, Terence, upward delivery or downward delivery?
Upward.
Yeah, because it's going up, yeah. Okay, because it's actually less than air. So this one is going to be upward delivery. Reason, because less dense than air. And okay, another reason is they are soluble in water, so you cannot use water displacement method. Yeah. So number 3, mixtures can be separated using a variety of techniques. Okay, a list of some techniques is given below. So we have all this. Okay, from this list, choose the most suitable technique. Yeah, the most suitable technique. Okay, so zinc sulfate crystals with aqueous zinc sulfate. So it means you want to get zinc sulfate crystal from aqueous zinc sulfate. So you must use crystallization. Yeah. Okay. And then, okay, this one maybe a lot of people do not know. Yeah, propane from a mixture of propane and butane. Yeah, so you want to actually separate them. Okay, propane from mixture of propane and butane, you have to use fractional distillation. Yeah, fractional distillation. Pure water from sea water. Okay, maybe we ask Kayla to try. How do you get pure water from seawater?
Filtration.
Filtration? No, because they mix, right? How do you do filtration?
Like a substance that won't mix with the products.
I think better use the simple distillation. Yeah, simple distillation. So you use simple distillation. And then chalk powder from a mixture of chalk powder and aqueous sodium chloride. Okay, I think chalk, they do not dissolve, so it's better to actually use filtration. Glycine from a mixture of amino acid, chromatography. Yeah. Okay, see whether you guys remember from the lesson yesterday. Amino acid, when you use the paper chromatography, okay, cannot be seen. Yeah. So what is the chemical that we add so that we can see? Okay, Kimberly. Yesterday I mentioned this. What is the chemical that we add? Okay, to see the separation. Okay, hurry up. The bell is already rang. Maybe Jessie, try.
Okay.
Locating agent, correct? Yeah, locating agent. Okay, locating agent. So anyway, iodine from a mixture of sand and iodine crystal. Okay, so iodine. Okay, if you want to separate iodine from mixture of sand and crystal. So maybe sublimation, yeah, because it's iodine is the solid over there. So you use sublimation. Okay. Okay, we will continue with our lesson. Okay, so if you look at this question number 4, okay, so potassium, okay, is going to be group 1 element. When potassium is added to cold water, a violent reaction occurs. Yeah, so complete the word equation for the reaction with potassium and cold water. So do remember, okay, group 1 metal, when they react with water, okay, they are going to give you salt and hydrogen gas. Yeah, so I'm going to actually write down. Okay, so this is going to be hydrogen gas. Okay, hydrogen gas, and the salt that they are going to actually form over here is going to be potassium hydroxide. How do we know? Yeah, potassium plus H2O. Okay, this H and OH. Okay, the OH will come over here, so KOH plus hydrogen gas. Okay, so no need to balance the equation, so you just need to know, okay, you are going to get potassium hydroxide. Okay, potassium hydroxide, okay, plus hydrogen gas. Now suggest 2 observations that will be made when potassium is added to cold water. Now do remember, the moment you have hydrogen gas being released, so that is actually an indication that, okay, you will see effervescence, or you will see bubbles. So you can actually say effervescence. Okay, effervescence, fizzing, or bubbles. Choose one, yeah. Okay, will appear. Okay, don't actually give everything. Effervescence, yeah, fizzing, or bubble. Okay, and then, okay, we also see metal. Okay, the metal, okay, they melt into a metal ball and burn, okay, because this is potassium, burn with lilac flame. Okay, because potassium is very reactive, yeah, so they will actually burn with lilac flame. Okay, so that's going to be the answer. 2 marks, yeah. Now, so cesium is another element in group 1. It has similar physical and chemical properties to other elements in group 1. So predict one physical property of cesium which is the same of that transition element, such as iron. Yeah, so basically cesium is going to be metal, so we are going to predict something that is same as transition elements such as iron. So all of them are metal, so able to conduct electricity. Okay, so I'll just write down able to conduct electricity. So if you want to write down able to conduct heat, yeah, please write that as well. Okay, electricity. Okay, because they want 1, you just give only 1. Yeah, don't give more than 1. So able to conduct electricity, but if you want, okay, able to conduct heat. Okay, and we know also, okay, metal. Okay, they are malleable. Okay, what is malleable? Malleable means ability, okay, to hammer them, okay, into different shape. Yeah, because of the presence of this positive metal cation, okay, and the delocalized electron. When you hammer them, they will slide on top of each other. Okay, so the possibility of having different shape is there. The same property, okay, we can actually use it for ductile. What is ductile? Ability to elongate them, okay, so that they become thin wires. Yeah, so that is going to be ductile. Shiny, okay, so you can actually use all that. Yeah, so predict 2 physical property of cesium which are different to those of transition elements such as iron. Okay, so we know cesium is going to be group 1. So group 1 are soft metal. Yeah, so I told you last time, okay, group 1. Okay, the metal is very soft. Yeah, even you can cut them using your ruler. Yeah, so they are very soft metal. Okay, so can be cut easily. Okay, and then when we look at strength, they are not going to have a very good strength. Okay, in comparison to iron. Another thing is maybe you can say that they have a low melting point or boiling point. Okay, because if you look at transition metals generally have higher melting point and boiling point. Okay, so we know that, okay, group 1 as they go down, because last time I told you also, okay, they are going to become bigger and bigger. So the positive ion and the delocalized electron, the distance is more, so it means that as you go down the group, okay, the melting point is going to become lower, okay, because the metallic bonding is going to be weaker. Okay, so predict two physical properties of cesium. Yeah, this is the main, you need to actually answer based on cesium. So soft, okay, one is soft, then iron. Number 2, okay, they are going to be, okay, so or can be cut easily. Okay, and then you can also mention that they have low melting and boiling point, low melting or low boiling point compared to iron. Okay, because transition metal, okay, generally they have high melting point and boiling point. Now, cesium reacts with non-metal phosphorus to form chemical compound called cesium phosphide. Okay, so do remember phosphorus here. Phosphorus is group 5. Okay, so they are going to form 5. They have 5 valence electrons, so they need 3 electrons to come in. So you will have P3 minus. Cesium is going to be group 1, so of course they are going to be plus. So what we are going to do is going to be this one times by 3, make it plus 3 so they can add together. So CS is going to be one element, no need to put a bracket, just put 3 and then P. Okay, this is the formula. Now draw a dot and cross diagram to show the electron arrangement in the 2 ions, okay, present, okay, in the cesium phosphide. Okay, so cesium, okay, there are 3 cesium, so I will draw cesium CS, okay, CS. So you want to show outer shell electrons only. Okay, so what happened, okay, after they lose 1 electron, okay, cesium is group 1. After they lose the 1 electron, it means the next shell, of course, they will have 8 electrons. Yeah, so I will draw the 8 electrons. So each 1 electron will go to phosphide. So P over there, okay, phosphide, okay, they are going to be group 15, so group 5. Okay, so they have 5 valence electron, so I will just draw 5, 1, okay, 2, 3, 4, 5. So 1 electron, okay, will come from cesium from this side, okay, from the other 2, okay, 1 electron and another electron. Yeah, so they have already reached octet structure. So do remember, okay, don't forget, put plus because they lose 1 electron, put plus, and this one 3 electron came, so 3 minus. Okay, so all done. Now phosphorus trichloride is a chemical compound of phosphorus and chlorine having the chemical formula PCl3. It's toxic, volatile. What's the meaning of volatile? Easy to change into gas. Yeah, and which reacts violently with water to produce HCl gas. Draw across a dot diagram to show the electron arrangement in a compound of PCl3. Okay, P, okay, group 5, Cl, group 7. So it means both of them are metal. So of course we are going to look into covalent compound. Okay, so for covalent compound, okay, so we are going to actually have Cl needs 1 more electron, 7 valence electron, they need 1. So P, okay, need to share 1 electron to Cl. But P on the other hand, they require 3 electron. Okay, so 1 electron that is being shared from 1 Cl is not enough. So phosphorus, okay, they require another 2 more Cl. Yeah, so if I draw over here, they have 5 valence electron. Okay, so 1, okay, 2, 3, 4, and 5 valence electron. Okay, and in order to share with one Cl, you need to put forward, okay, your own electron. Yeah, so for now, the electron I will remove first. Okay, I will draw the Cl. Okay, so 1, 2, 3. So these are Cl. So we know that Cl, okay, they will actually give 1. Okay, so they have 7. They require 1. So if they require 1, okay, of course they need to share 1. Yeah, so they share. Okay, similar. Okay, so if you have 1, okay, 1, okay, 7. Okay, so they will take 1 from P. Okay, so the blue ink is showing the electrons from phosphorus. Phosphorus has 5 electrons, so 5 valence electrons. So the remaining 2 electrons, I put it outside. Okay, so this is going to be the outer shell electrons only for PCl3. Yeah, what type of bonding does phosphorus trichloride molecule have? You can clearly see what kind of bonding. This is sharing of electrons, so this is going to be covalent bond. Now, explain in terms of electron how the bonding in phosphorus trichloride is formed. Like just now I told you, sharing of electron. So the electrons, okay, are shared with each other. Okay, the electrons are shared between, okay, phosphorus and chlorine. Now, naturally occurring lithium, okay, is composed of 2 stable isotopes, okay, lithium-6 and lithium-7. Do remember what's the meaning of lithium? Isotope. Isotope is is an element, okay, that has the same proton number, okay, but different neutron number, or element that has the same atomic number but different mass number. Yeah, that's actually isotope. So yeah, they even define the term isotope. Yeah, they have the same proton number, different nuclear number. Okay, so atom of the same element that has same number of proton but different number of electrons, neutron. Now state in terms of total number of electrons, neutron and proton, one difference and one similarity between this lithium isotope. I think the number here is actually similar with our definition. So what I'll do, I'll just change our definition a bit. Atom of the same element that has the same proton number, okay, proton number, but different nuclear number. So what's the difference? Okay, different number of neutron. Similarity, same number of electron and proton. Okay, all isotopes of lithium react, okay, with dilute HCl acid, okay, dilute HCl, okay, to form hydrogen gas and a salt. Okay, why do all isotopes of lithium react in the same way? Because they have same number of electron. So if they have same number of electron, it means the valence electron is also going to be the same. They are going to be reacting as the same manner. Yeah, so because, okay, they have the same valence number of valence electrons. Now lithium chloride conducts electricity when molten, okay, but not in solid state. Why? Yeah, because if they are molten, the ions are free to move. Yeah, but if it is in solid state, they are going to be, because they are ionic, okay, they are going to be in a regular lattice. Okay, so because in lattice, okay, each of these ion, Li plus ion and Cl minus ion, they are bonded to each other with strong and multiple ionic bonds. Okay, so they cannot actually, they are not able to move. They are not free moving. So if they are not free moving, of course they cannot conduct electricity. So you need to tell lithium chloride, okay, is ionic compound. In solid form, the ions are not able to move, but in molten condition, ions are mobile, means able to move, yeah, and carries, okay, because ions means they carry charge. Okay, so when they actually carry charge, okay, of course they can conduct electricity. Now lithium is group 1 metal. Describe the structure and bonding of metals. Include a label diagram in your answer. Yeah, the structure is, okay, you are going to have many, okay, metal cation. Okay, so many metal cations will be there, and then you are going to have, okay, delocalized electrons, okay, and then the bonding between them is going to be, you will have a strong electrostatic forces of attraction between the positive metal ion and the delocalized electron. So the structure is, okay, closely packed metal cations surrounded by delocalized electrons. The bonding is called strong electrostatic forces of attraction between metal cation and delocalized electrons. So you can draw as well. Okay, this is positive, 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 positive. Then okay, if you have this, okay, so you will have a lot of electrons. Okay, so we call it a fixed cation. This is going to be C of delocalized electron. Okay, done. Okay, the paper is done.